Assalamualaikum and a very good day to everyone. Today I'm going to teach you on how to phrase regression. So the reason why you do regression is because you want to know what is the most significant factors that influence your DV. So what is the most significant IVs that influence your DV, and that's the reason why you do regression. So before you are able to phrase regression, I'm going to teach you on how to read regression analysis or regression output. So here is going to be, we're going to go to the first example. So practically you're going to get 4 tables, and the 3 most important tables would be model summary. In sequence is going to be model summary, ANOVA and coefficients. So basically once you get your model summary, the figure that you have to read is going to be R square. So this is the R square of 0.181. So what you really have to do is to multiply this R square with 100%. So you will get 18.1%. So you look at the predictors. So there are 3 predictors besides your constant. You have competence, relatedness, and autonomy. And your DV is concealing. So with 1 DV and 3 IVs. So what is the meaning of R square? So your IVs here, or your predictors here, are representing your DV as much as 18.1%. So that is the meaning of R square. So once you're done with R square, you move on to ANOVA. So when you look at ANOVA, that is actually called as analysis of variance. So how to read ANOVA after model summary? You have to read from your right to your left. So first you have to look at the significant value here. If this is significant, the whole model is significant. But if this is not significant, the whole model is not significant. So once this is significant, if we look at the figure, it is significant because the figure is 0.000, which is lower than 0.05. So it means you can read the F value. So F value here is actually representing the regression value. So F value is actually, or capital F is 6.650, and the next figure is for you to be looking at your DF, or degree of freedom. So degree of freedom of regression is calculated. So you have to take the first 2 figures here, 3 and 90. So you have to jot all the figures down because you need all the figures to phrase regression later. So once you're done with ANOVA, let's move on to coefficients. If we look at the coefficients, there are many columns here, but you have to find the significant column. If you look at the row here, the first row is representing constant, and you have to read based on your IV1, IV2, and IV3. So if you look at all the significant values here, only one IV that is significant, that is autonomy, because the figure here is lower than 0.05. The rest, relatedness and competence, are not significant because the significant values are bigger than 0.05. So you have to look at this figure, significant, and after that you have to look at your unstandardized coefficients beta. Unstandardized coefficients B. So you have to read the constant figure of unstandardized coefficients B, as well as your autonomy, the one that is significant, that is actually negative 2.385, while the constant for this research is 43.697. So you have to jot all the figures down in order for you to regress later. So now let's move on to another example. So basically you will be getting 4 tables, but what you really have to look at is going to be your model summary, ANOVA, and coefficients. Your model summary here, you have to look at your R square. So here the DV is Y, and the predictor only 1, we have X1. So here, what is the meaning of R square? You have to multiply with 100%. You will get 30% of your IV representing your DV. So since you have only 1, so only 1 IV is representing your DV as much as 30%. So the next thing that you have to be looking is ANOVA by finding the significant value, or the significant column. So apparently this is significant because the figure is lower than 0.05. And then you can read the F value, and the F value is 41.936, And the DF, you have to take the first two figures, 1 and 98. And after that, you have to go to your coefficients. So basically, there is only 1 here. Is this significant? The answer is yes, because the figure is lower than 0.05. And the next thing that you have to be reading is going to be your unstandardized coefficients B. That is going to be 366.458. And your x1 here is 0.779. So now let's try to phrase regression. So here, when you want to phrase regression, you will be given the numbers here as well. But please exclude the numbers if you want to write or if you want to phrase regression later. So the numbers are actually going to guide you of what to write first, second, fourth, and so on. So the first thing that you have to be writing is going to be a multiple linear regression was calculated to predict employee satisfaction as your DV based on motivation. If you have only one, you write only one IV here. But if you have more than one, you have to put all your IVs, you have to write all your IVs here. Alright, before the full stop. So a significant regression equation was found. How do you know it is significant? Because you have to look at ANOVA, the p-value of ANOVA just now, if you can recall. So how to write it is going to be F. You have to delete this bracket. Yeah? You have to delete this bracket, and you have to start with big or capital F. In bracket is going to be your DF. So where to get the F value is actually from ANOVA. Where to get the DF is actually from ANOVA is stated here. Equals to F value that you can get from ANOVA, comma, the p-value is also gotten from ANOVA with an r-square of 0.993 that you can get from r-square. So here you do not have to multiply with 100. It's enough for you to just write the decimal numbers. But in order for you to understand, you have to multiply with 100. So it means 99.3% of the IV is representing the DV. That is the meaning of r-square from your model summary. After that, you have to continue the sentence with number 3. So respondents predicted DV is equal to. So this is a little bit tedious, but I need you to pay attention. So here you are given linear formula. So what is the formula? Y equals to A plus BX. This is depending of how many IVs that are significant. So the DV here, you have to write the DV equals to constant. So A is representing the constant value of coefficients from coefficients table, minus or plus the significant value based on your unstandardized coefficient B. So you have to write the figure of your unstandardized coefficient B. So if it is minus, you put the figure minus here. Minus symbol minus 39.133 of IV1 plus 2.101 of IV2, where IVs are coded as 1 to 5. This is your continuum, this is your scale. If you have 5 scales, 1 is strongly disagree, 5 is strongly agree, depending on your scale. If you have 6, you have to put 6. If you have 7, you have to put 7, 1 to 7. So since there are only 2 IVs that are significant, so you can conclude that both IVs were significant predictors. So if there is only one, you have to write only one IV was significant predictor, depending on how many factors that are significant. So that is how you phrase your regression based on APA style. So I think that's all from me. Assalamualaikum and bye-bye.